Now let's continue. Now let's talk about, we had the technical error. So now let's talk about the potential energy. Now I was explaining that the potential energy, having a look at this cat, it is actually on a tree above the ground with a certain height. When you talk about the energy, when you talk about the potential energy, is energy possessed by an object due to its position or state. But in this case, we're going to refer to this as gravitational potential energy because it is above the height. Now, in this case, we can see that the formula that we use mathematically to calculate the potential energy is mass multiplied by gravitational acceleration multiplied by the height. And again, the SI units for potential energy is going to be joules, since well, potential energy is indeed an energy. Now, have a look at this, right? This cat, gravity wants to pull it down. This is the weight of the cat. Remember, weight of the cat also refers to the gravitational force, Fg, which is gravitational force is the same as weight, is the same as mg. So now, the weight wants to pull this cat on the ground. So, but this cat, it is above the height. It is above the ground for a certain height. So that means it is possessing gravitational potential energy. Okay. Now let's have a look at this example once more. Again, they say to us, a load with a mass 5 kilogram was lifted up by a pulley to the height of 0.8 meters for pile work. Use your GS 9.81 meters per second squared. What is potential energy? The load. Simple, we're going to say our potential energy is going to be equals to mass multiplied by gravitational acceleration multiplied by the height. In this case, our mass, it is in kilogram. That's positive. We have 5 kilograms. And then our acceleration, it is actually in meters per second squared, which is correct, 9.81 meters per second. And then our height, it's going to be 0.8 meters. And then when we punch this on our calculator, it's simple. We're going to say 5 multiplied by 9.81 multiplied by 0.8. And therefore, our gravitational potential energy will be 39.24 joules. Make sure that each and every time when you calculate your values, you write your units at the end. So this is how we simply calculate the gravitational potential energy. So meaning this block over here lifted by a pulley, it will possess this amount of energy. It's very important. Okay. Right. Here's the answer. We have already worked it out. Now, like I said, this slide, it is designed for a quick summary before we can do the exam questions. After this slide, I believe that we all gonna have an understanding on how these concepts actually unfolds, okay? So now, here, we have the state of, the principle of conservation energy. So now, this is what we know. You'll see this when you get at the university. It is called first law of thermodynamics, that the energy can never be created nor destroyed, but it can be formed from one form to the other form. And the total energy will always be constant. If you decide to convert electrical energy into a light energy, what's going to happen? The energy will always be constant. The energy will always be conserved. Okay? Right. So, a quick review on what we did so far. We spoke about work, which is an energy, and we saw how to calculate work mathematically. We use the force and the displacement and the angle between the force and the displacement, right? And then we spoke about types of energies. And then we spoke about the kinetic energy and the potential energy, right? Now here we are talking about the principle of energy. Remember, like I said, this topic is basically on energy more than anything else. Right. This is how we know energy can be transformed from one form to the other. Like I said, it's just a simple concept that we all know by now. A chemical energy can be transformed into kinetic energy plus potential energy, and then less kinetic energy and more potential energy to heat and kinetic or molecular energy now of molecules. Now, this is what is happening. We have a cannon over there, and then when it shoots the bullet, what's going to happen is we have the chemical reaction that is taking place inside of this so that the bullet can shoot off out of the cannon. But you need to understand that, look at this. Look at the height. From this point to that point, we have height which is above the ground or which is above the Earth's surface. Now, at this point in time, what is the kinetic energy of the bullet? I mean, sorry, not the kinetic energy. I want to start with the potential energy. Let's talk about the potential energy first, okay? What is the potential energy of this bullet? It's going to be a certain value. It's fine. But you need to understand that this bullet, it continuously projecting upwards, and it reached the maximum height where it now will change its position. It will now, this is a turning point. There's like graph, mathematics, parabolic function. This is the turning point whereby the bullet will start to take a different turn. At the very same time, it's a vertical projectile. Eh? So this is the maximum height of the bullet, right? Look at this height and look at that height. What's the difference between the gravitational potential energy? The gravitational potential energy at this point and the gravitational potential energy at this point, it is not the same. Here we have more gravitational potential energy compared to this point over there. Because the height, it is actually directly proportional to the gravitational potential energy. And therefore, let's talk about the kinetic energy. Here we have more kinetic energy, and then there we have less kinetic energy. Use the basic that we have learned under the vertical projectile. Remember, when the object is moving upwards, what is happening with the velocity? The velocity is decreasing. Remember, normally at maximum height, we say the velocity is 0. So meaning it was projected with a certain, let's say maybe 350 meters per second. And then the velocity continued to decrease, So at this point in time, we have a high kinetic energy compared to kinetic energy at this point, because we know that the kinetic energy depends on the velocity of a moving object. So kinetic energy and potential energy, they give what you call the mechanical energy, but we'll learn more about that, okay? So now, and therefore, your bullet's going to crash, and there's going to be a heat, and the kinetic energy of the molecules will disperse, they will move far apart from one another, they attain a kinetic energy, they move far apart from each other. Therefore, we have heat, because we know that's the purpose of the bullet. Okay, right. So how energy transforms from one form to the other form, it's also very important because we're going to learn more about the kinetic energy, the mechanical energy, which is the combination of the potential energy and the kinetic energy. Okay, it's called the mechanical energy. It's mechanics. If maybe you get to the university, you want to do mechanics, mechanical engineering, this is what you'll be dealing with. Okay, it's all about the motion, moving objects. Okay? Right. Now, here's a conservation of mechanical energy, which is what I have already spoke about. Now let's have a look at the diagram. Here's the thing. We have a car. It's gonna move down the slope, it's gonna move down the slope, it's gonna move down the slope until it reaches this point over here, right? Look, the car is moving, but it's moving. What kind of energy is the car possessing? Look, it's in motion, kinetic energy. But you have to bear in mind that this car, it is moving down the slope. And what's happening is it is above a height. If I view this car in this section, we can see that the car will be somewhere else over here, and the car will be moving down the slope. The car will be moving down the slope. And then if the car it is moving down the slope, remember this is the ground. Here we have the ground, and the car is moving down the slope. And then we have the height at which the car it is starting to move from. And look what is happening with the height. The height is decreasing. The height is decreasing. The height it is decreasing. The height is decreasing. So that means the gravitational potential energy of the car, it is decreasing while the car it is moving down the slope, which is the same. From here to here, the car it is actually moving down the slope, whereby the gravitational potential energy it is actually decreasing. Right, fine. Now let's talk about the kinetic energy. At this point in time, the car it is stationary, whereby its initial velocity is 0 meters per second. So when this car is at this point in time, its kinetic energy is 0, because remember kinetic energy, we need velocity mv squared. This one will be mgh. So that's why here I was talking about height, but when you talk about the kinetic energy, we're going to talk about the velocity. So at this point in time, the velocity of the car, it is most definitely 0 because it is at rest. So when you want to determine the kinetic energy of this car at this point, it is most definitely going to be 0. Hence why here we have 0 at this point. But look, the car is moving down the slope, right? And the moment the car starts to move down the slope, what is changing? The mass will always be constant. The mass of the car will be constant. Even for gravitational potential energy, the mass is constant, the gravitational acceleration is constant. The only thing that is changing here is height. And even this side for kinetic energy, the mass is constant. The only variable that is changing over here is the velocity. So that means if this car moves down the slope, the velocity will increase. Okay? Therefore, as the velocity, look, velocity is directly proportional to kinetic energy. As the velocity increase down the slope, the kinetic energy increase. So look, here we have we have two forms of energies that are working antagonistically, meaning the other energy is going up, the other energy is going down. Kinetic energy is increasing, gravitational potential energy is decreasing. Why is gravitational potential energy decreasing? It's because of height is decreasing, moving down the slope. And then why kinetic energy is increasing? It's increasing because the velocity of the car is increasing, moving down the slope. So the combination of these two types of energies, which is this one over here, we're gonna call it what? EK. And remember, what did we say? We said that the total energy will always remain constant. The reason why kinetic energy increase and potential energy decrease is so that when the other one increase, the other one decrease, they meet each other halfway, and then when we add them together, they maintain the same value through the entire motion of an object. Okay? That's fine. So that means the combination of these two energies, like I said, we're going to call them the mechanical energy. Now it's time for questions. Now let's apply the concept and formula of work, energy, and power in solving the related problems. Now here we have Nelly. If little Nelly Newton lifts a 40 kilogram body a distance of 0.25 meters in 2 seconds, then what is the power delivered by little Nelly's biceps? So we want that power delivered by little Nelly's biceps if we are given these parameters over here. Now, what is provided to us at this point in time? We are given the mass of Nelly. Nelly's mass in this case, it's most definitely going to be 40 kilograms. And the distance is going to be, I'll say changing, it's in Y, it's vertical motion. I'll say change in Y, it's going to be 0.25 meters. And therefore the time is going to be 2 seconds. So what do we want to calculate? We want to calculate power delivered by little Nelly's biceps, right? Now, in order for us to calculate power, we're going to use the formula that says power is equals to, this is what you know, the rate at which work is done, or the rate at which energy is done. So we want to determine the rate at which nearly is done to do what? To lift, yeah, whatever, bicep. So the energy is going to be power is equal, the power is going to be work divided by change in time. Now let's talk about everything provided in this case, right? Do we have work on the data provided? No, we don't have work at all. Do we have change in time? Yeah, we are safe. We do have change in time, which is 2 seconds. But now let's talk about these two guys over here. How is this two actually going to help us to determine work? Now, if we talk about work, the formula that we know on how to calculate work, it is actually going to be work done by nearly is equals to force multiplied by change in x cos theta. This is the formula that we use to calculate work. Now let's come here. Do we have force? No, we don't have force. Do we have change in x? Now in this case, because we are dealing with vertical motion, I will change my change in x into change in y, okay? Because we are actually dealing with vertical motion, not the horizontal motion, okay? Also pay attention to that. It's very important. What am I doing now? I want to erase this. I don't know what's happening here now. Okay, let me just fix that. So work multiply by change. I said here is going to be change. It's going to be changing y, right? So now this is what is happening. Let's think of a free body diagram of Nelly. Nelly has a free body diagram like this. If little Nelly Newton lift her 40 kg a distance of this in 2 seconds, then what is the power delivered by little Nelly? So now we're going to have to pay attention that there is a force of gravity, which will be our force in this case, that's going to play a role. So we have force of gravity, which is denoted by mass of Nelly multiplied by gravitational acceleration. So that means in this case, we can work out the force using mass of Nelly and the gravitational acceleration. Do we have change in y? Man, we do have change in y. Do we have the angle between force and the change in y? Now, this is where it's going to get a little bit hectic, and this is where you're going to have to pay attention when you deal with this question. I said to you, theta is the angle between force and the displacement. So it's either the force is acting parallel with the displacement, or the force is acting anti-parallel with the displacement. Be careful about that, okay? Because you can always get your things wrong. So I said to you to determine the directions, use a protractor. So because here we are dealing with vertical motion, so that means you can simply say, take your protractor to be like this. Turn your protector like this. This is how I would do my thing so that I understand or I don't complicate my life. This is my protractor, right? I say here it's going to be my 0 degrees. And then here I'm going to say it's 180 degrees. And then obviously there will be 90 degrees. I'm not interested on 90 degrees. I'm interested between 0 and 180 degrees. So you look at the direction of the displacement. Is the displacement up or is the displacement down? Is the force up or is the force down? And therefore, if the force is up, and then maybe is the displacement down, therefore we're gonna say the force and the displacement, they're gonna be anti-parallel. The other one will be moving in 0 degrees, the other one will be moving in 180 degrees. So be careful about that. Now, here's my solution. Like I said, instead of having a force, we're gonna use mg to calculate work. And then we have the displacement in this case. And then our displacement, it is given to be 0.25, right? But how to calculate force? We're going to say 40 multiplied by 9,8. This is the force, mg. Mass is 40. And then the gravitational acceleration, they say it's 9,81. And then the displacement, which is changing y in this case, is going to be 0,25 meters. And when we punch this on our calculator, it's going to be 100 joules. So in this case, that means the weight and the displacement are in the same direction, okay? Because the weight, it is moving downwards, like I indicated over there, and the displacement, it is also downwards. But you want to understand, how is the displacement downwards? Reading the statement, they said that Nelly Newton lifts her 40 kg body a distance of, meaning she lifts her body away from this distance. So what is pulling her down to that distance of 0,25? It is the weight, it is mg that is pulling her away towards that direction. So they are in the same direction. But if we were talking about the force applied by Nelly's bicep, we're going to say the angle between force applied by Nelly's bicep and the displacement, it was going to be 180 degrees. So be careful about that. Okay? Be a little bit careful about that. Therefore, now let's calculate the power. So in order for us to calculate power, now we know the work done, right? So we said the power is given by the rate at which work is done. We are given time, which is 2 seconds. We have just calculated work. And therefore, we have 50 watts, which is the power delivered by little Nelly's biceps. And then we are done. If we have